All right, welcome everyone. Welcome, great to see you all in person, as well to those of you watching online. So here's the thing. Agents today, they're no longer confined to a chat box. They're not waiting for you and I to tell them what to do. They're taking action. They're calling tools. They're running workflows end-to-end that are pretty complex that would have been almost unimaginable just a few months ago. So the problem is this. It's not about capabilities anymore. Agents are plenty capable, and we're a lot more productive as a result of that. No, what we want is we want agents to run safely and predictably. And in this session, we're going to learn all about the capabilities Windows is providing to help your agents do just that. My name is Kirupa. I'm a product manager on the Windows platform and developer team. I'm joined by Stuart, an architect, also on the Windows platform and developer team, and Patrick, a product manager at GitHub. You'll be hearing plenty from Stuart and Patrick throughout this session. Now, before we go into the technical details, I want to take a step back. As you can see from these headlines, the way agents are being used today, it's not great. As agents are gaining more capabilities and working with greater autonomy, they're causing real problems, either in the wild or maybe even within our own organizations. And if I had to generalize, the reason is that we're moving very quickly from AI that responds and answers to AI that acts with agency. So when an agent makes a small mistake, like sending an unwanted email or modifying a file or even making something public it shouldn't, it gets amplified. It creates a chain reaction. The blast radius of the damage it causes is much larger. Here's a great example where you're using an agent, it's doing some coding, deletes your production database. Not great. Even in situations where you might have seen this example hitting your news feeds a short while ago, where the agent is operating on your email, you're telling it to stop, don't delete it, agent acknowledges, goes ahead and deletes it anyway. These are the kinds of examples that we need to close at a platform layer. Because when an agent can operate on the things that matter to us, files, code, email, all the systems you and I rely on, we cannot rely on the agent to self-govern. We cannot rely on the agent to basically follow good intentions. It's even best effort prompting and prompt engineering can't solve this either. It really requires a more holistic solution. And also because it's not just the agent itself. The entire environment the agent operates in is a potential risk vector. An agent can be talking to humans, and there's risk. Agent to tools, agent to applications, agent to agent, or even agent to LLM. All of these are risk vectors, and each of them has a risk profile that we cannot possibly account for, all from just our own vantage point. And this is not just a theoretical problem, so I'm going to move away from examples and headlines to something that teams are actively exploring. And I'm going to turn it over to Patrick to talk about what he and the GitHub Copilot team have identified.
Wonderful. Thanks, Kirupa. At GitHub, we get the unique opportunity to see where modern model performance intersects with user behavior and how those trends alter over time. If you take a look at the Copilot CLI, one of the most common occurrences that happens over time is users start auto-approving, removing the gates, and letting their agents run for longer and longer sessions. When you scale it up to the Copilot SDK, it rides on top of our Copilot CLI server. But one of the unique differences that we did when we built the Copilot SDK was design it in a way that was made for SDK integrators and not for Copilot CLI users. What that led to was a mismatch between our permissions model inside of our SDK and one in our CLI. Certain integrators expected our SDK to be fully configurable, come with nothing out of the box already set. All the CLI users expected it to protect their current working directory and other artifacts on their system. When you look a little bit farther into the orchestration side, our orchestrator inside of the Copilot CLI and SDK has become much more powerful, especially over the last 6 months. Where our jobs typically ran from 3 to 5 to 10 minutes or so, they can now run for 30 minutes or more, which means that the problems in these two first segments compound exponentially with time, especially as agents get more and more powerful.
Thank you, Patrick. So the problem is very clear. Agents are operating with high agency, and they're running with limited to no guardrails. Then the question then shifts to, what does a platform need to provide to make agents safe by design? That's where Windows comes in. From its very beginning, Windows has always evolved to handle the needs of its users. The part that's changed is this. The definition of a user is changing. What is a user? Today, they now include agents acting on their behalf, and that detail fundamentally changes how Windows and the platform need to react. And to account for this, there are 3 key platform capabilities that we're introducing that when agents adopt, they can work with agents as a new type of user and also ensuring agents can run safely and reliably. Let's walk through very quickly what these primitives are, and we'll go into more detail in a few moments. First, it's agent identity. The agent needs to have an identity distinct from that of the human user. Second is containment. We don't want our agent to have full access to all the capabilities that we have as people. We can't give it unfettered access to all of our files and all of our data. What we need to have agents running in a controlled environment where their blast radius is limited. And the last one is manageability. For many of us, that means an IT admin can deploy, monitor, govern, and enforce the policies that dictate what an agent can do and also what it cannot do. So to dive deeper into this, starting with identity, I'm going to turn it over to Stuart.
Great. Thank you, Kirupa. So as Kirupa said, one of the most interesting things about agents is what is the identity of an agent? I'm here to tell you, agents aren't you. No matter what we do today, the funny thing about where we got to is most agents run as you, the user. If you use a CLI, they're running in your session, they have access to all your data. The program itself is controlling what they do, but they're not you. Imagine what would happen if the agent could get access to almost anything from you and do whatever it wants. We need the system to be able to enforce a separation between an agent and you, and to be able to enforce the capabilities and promises that define what an agent is different than what a user is. In general, what a user is and what they do on a machine today can have a lot more rights than some of what we want our agents to be able to do. Do you want your agent to be admin on your machine? It's a question that you should ask. So for us, the way we think about it is this. Agents are a new type of identity in the system. When you think about users and devices and applications, we identify those on the system. Agents aren't just the processes of the CLI that you're using or whatever agentic application that you're using. They themselves are an intrinsic first-class entity on the system. Just like users, apps, and devices, they need to have a security principle. We need to be able to make assertions about them, things that define security permissions that the system itself can enforce. We need to be able to author policies that define what are the things that they are allowed to be members of, to join, to understand in general what an agent is allowed to do in the system. And whatever they do needs to be audited by the system. We need to have logs that show what an agent does so that we can separate the actions of the agent from the actions of the user itself. So with that, we're going to do a quick demonstration here. It'll show you, we have worked with the OpenClaw team to work on showing how an agent like OpenClaw, an agentic system, can function in an operating environment where it is separated from you, the user. In this demo, what we'll see is this is a Teams chat. And in Kirupa's Teams chat, he will go in and talk to his OpenClaw gateway node. The OpenClaw gateway node is running in a separate session on the same machine, but as a different user account and in a different session, which means all of its processes are separated from the desktop, from the windows, and from all the processes that are here. And by default, everything that it tries to accomplish has no access to what Kirupa himself is doing. So as he interacts with the agent, it is fully separated, fully identified by Windows at its core. So that is how we look at agent identity. It is not you, and it should run separated from you. So how do we? So after agent identity, the next thing that Kirupa introduced was containment. A really important thing about agents is that when agents operate, as Kirupa said, they need a blast radius, the things that they can accomplish. What's really important is that for us to understand, agents are non-deterministic. Different than the software that you run today, when we install an application, at compile time, what the software can do is already defined. Our agents today write their own software. They evolve, they change on a very frequent basis. And as they operate with agency, they make decisions themselves, not your mouse clicks, but the decision of the software itself. That non-determinism is something that we need to think about how that happens in the system. When an agent can choose its own actions at runtime, that makes it unpredictable. But because it's unpredictable, it doesn't mean that it's uncontrollable. It means that what it needs is a boundary around what it can do, a boundary that's understandable, that we can understand what it can and cannot do. That isolation boundary allows us to control risk and to understand what is the profile of risk that that agent can have against our system. Also, what's really interesting is once you put an agent inside of one of these sandboxes, it allows us to enforce the design of least privilege, which is we can take the actions of an agent, its individual actions, and put it inside of a sandbox and let that one sandbox for that one action have policy that defines just what it can do. And then when the agent decides to do something else, we'll build another sandbox for that. What that means is that the sandboxes that we're going to build need to scale. The isolation boundary needs to be proportionate to the risk and proportionate to the action that's happening. For that, we've introduced what we call the Microsoft Execution Containers Library. The MXC library is a library that's designed to help you create containers based on policy. The developer and the agent can declare the security requirements of their agent and the agent's actions. The library will then compile that together and match that against the policies of the system and the policies defined by IT, governed by tools that we're used to using to deploy things, to manage them, and monitor them. Once that match has occurred, the MXC library will then look at the native OS platform and try to assemble together the right container for the job. That process is something we call dynamic composition. That means that when an agent runs, there isn't a fixed container. The MXC library allows you to create the container on the fly. It will, as I said, take the definition of the application that you want to run or the actual action. It will take the user's consent and permissions. It will take the policy defined by IT and try to, from that, craft together a configuration of a container. With that configuration, it will then look at the operating system primitives that are available for it to use. It's not just Windows. It's Windows, WSL, Linux, a full cross-platform library that can scale everything from tiny, small processes to VMs, micro VMs, Firecracker-style micro VMs, all the way up to cloud-based PCs. So MXC really allows us to define a security boundary that's designed and proportionate to the task that we want to accomplish. So what does that really mean for us as developers? How do we use this? Well, let's dive in a little bit deeper. MXC, as I said, is a declarative approach. What it's really designed to say is, let's look at the guardrails we want to put in place for the components of our agent. What is the composition of the container? What are the security requirements? And what does the workload shape look like? So as we dig into a little detail, this is a Python script. That Python script needs to be able to access my certificates to authenticate somewhere in the system. It needs to be able to run within a certain time frame. It can only access read-write locations very much specified by here. Everything else is denied by default. What network am I allowed to talk to? I can only talk to the GitHub API server. And even more restrictive, I can't touch the UI of anything else on the system, but I can see the clipboard and read from it if something has done that. That allows me to specify with very fine-grained detail what the container is and what the action of the agent can do. So let's do a quick demo. I'm going to escape out of here and do something really dangerous and bring up a command prompt. So the first thing I'm going to show you here is a really simple demo. This is a, it's only showing PowerPoint.
Only showing.
Oh, that's a problem.
Let's try duplicating the screen by any chance.
Oh, there we go. Fantastic. Awesome. Thank you. All right. So here is my command prompt. So from the command prompt, what I'll show you here quickly is this is essentially that script here. I built for here a script that will create a PowerPoint file. That PowerPoint slide will be generated using a Python script. That Python script will launch and create a the PowerPoint file in this build demo folder. So if I come over here and I will tell this to run, what you'll see here is, oh, I have a mistake. It says I can't do it. The agent is run that script inside of the container. The container has failed. Why has it failed? Because it said access to the build demo folder is read-only. Let's come in here. We'll change that quickly. And we'll run it again. And what you see here is, this is PowerPoint file generated by my script. Awesome. Okay. So that's a simple demo. But the reality of it is, what are we really here for? We're here to contain an agent that may have written scripts that aren't perfect. So what I did here is I created a demo that shows an agent running and a monitor of the agent. This agent is purposefully malicious and will try to escape its boundaries. The first thing it's going to do is try to see if it can get around the file system, write to the user's SAM hive, see if it can steal ntuser.dat, see if it can grab the user's credentials. And what we'll see here is this. On the right-hand side, those red things are it firing and hitting the boundaries of the sandbox itself. So listening to events from the sandbox, we can tell that the sandbox is enforcing the constraints here. So this is in live, this running demo, pounding against the sandbox, us listening to that. What can a developer do with that? Two things. One, you can monitor and observe what actually is happening of the agent. Two, if you want to know why did my agent fail, you can pull that data back in for the next loop around and understand how to evolve and make better policy for your agent. So there's that. The last thing I want to show you quickly is this. As I said before, we have many different sizes and shapes of containers. The smallest one is based on a technology we call Hyperlight. Hyperlight is a small VMM that will start here a container, which is a hardware-backed virtual machine. The hardware-backed virtual machine runs a tiny operating system called 𝗫𝗫𝗀𝗃 that is about 10 megabytes in size. It will start up and run that same PowerPoint file very fast. Boom. And if we look, that is the same exact script of the other side that generated the same PowerPoint file, loaded incredibly fast in a very small amount of memory and fully protected by the hypervisor. So with that, my demo's actually succeeded, which is fantastic. Exactly. So given all that, as Kirupa said, all those things put together are useful ingredients, but the agent itself still needs to be managed. The platform that we operate in needs to make sure that the management system that we have can guarantee that the agents are operating within defined policies. So IT or you, the user, need to be able to specify what you do and don't allow your agents to do. The policies need to be able to control what can the agent access. What are the actions they are allowed to do? And as we showed, how do we observe those actions to make sure that they are correct? In general, we also believe that one of the most important things for you as a developer is to think about the concept we call supervision, which is that agents need to operate with clear oversight. The user needs to understand whether it is a human-in-the-loop agent or a fully autonomous agent. They need to be able to trust what it can do. The most important thing is that as an agent becomes more and more autonomous, that trust needs to be something that we build upon to make sure the user believes and IT believes they still have operational control. We think you need to think about how do you surface the intent of your agent at natural waypoints. Make sure that even though an agent can do things fully autonomously, it should still ensure that it's notifying the user, providing places for it to compensate if there are problems. Why? Because agents make mistakes. Assume that your agent is not perfect and that you've designed it in such a way that your agent can compensate and bring the human user into the loop to compensate for it. And make sure that you think of consent as a continuous thing, not just, as Patrick said, one time you set it up this way and it's perfect. Agents will evolve policy and change and need to keep asking the user. Why? Because we earn autonomy with evidence. The more that we can build confidence in our users to trust the things that we do, that's where we'll build more and stronger and richer autonomous systems. With that, we believe in Windows, there's a lot of features that are in the platform and that we can add that help you use the surfaces that are there. The activity that your agent is running under can surface that using Windows channels. It can use notifications, it can use many things that exist there, as well as the guardrails and safety primitives that we helped you show today. Further, if an agent has its own identity, the provenance of its code and an audit of what it does is a natural part of what the OS does. So with that, I'll turn it over to Patrick.
Wonderful. In the Copilot CLI and SDK, we started all the way over there. No sandboxes, no controls, basic guardrails in the application. If the user hit the wrong prompt at the wrong point in time, they ended up in a land where they could do a lot more damage than they expected. Today, we're happy to announce that the Copilot CLI and SDK, through our collaboration with the team over at Windows, we're able to ship a sandbox out of box, which is currently under the experimental flag. We'll be moving to GA in the future, so it'll become a default on solution. In the future, we're moving to a fully isolated state where you'll take the entire agentic host, shove it inside of a safe environment, and allow it to execute freely, enabling you to accomplish a wider range of jobs end to end without supervising the agent directly or worrying about what it's doing and where it's going. To look at this in a more practical sense, let's break down a little bit of what Stuart showed into 3 short little demos. Inside of the GitHub Copilot CLI, like I mentioned, you can actually fire it open today. And if you've enabled the experimental flag, you will be able to make sure it's actually running. Can you play on that one for me? Perfect. You will be able to access a /sandbox/ commands, which not only will allow you to turn it on and off, but as you'll see, you'll have some quick, handy out-of-the-box options that allow you to configure policy. You can turn on and off the sandbox. You can set the file system configuration. Notice include working directory is already there, and the policy will clear after it's done. If we just enable the file system protections, and we ask the agent to just go off and delete all the files on our desktop, we probably don't really want that to happen, but it's a good test for the agent itself. We experienced our normal permissions prompt, and we said, yes, go delete everything on my desktop, which definitely don't want that to occur. I have plenty there. And you'll notice that the agent, because it has the sandbox enabled, it's able to, 1, block the deletion of all the files on the desktop, protection number 1. 2, the agent's able to identify that it's actually operating with the sandbox on, so you're aware of what's providing that protection. And then 3, there are some options there and some next level guidance for what you can do next to move your way around the sandbox if you need to. If we look at the next piece, go for one for me over there, perfect. We go forward to restricting outbound network access. You have a similar opportunity just off of the file system and towards the network ingress and egress to your system. If you look at the network tab, you can allow outbound connections. You can allow local network. They're separate, so you have a couple of different flex options there. But the beautiful thing is, if you ask the agent to do something as sketchy and dangerous as turn your private repository public, which might be company IP, the agent can actually use those filters to block certain actions and prevent you from making dangerous calls outside the system. And while this might seem like a basic demo of me asking it to do something and expecting some guidance, the thing to be aware of is agents are still exposed to prompt injection attacks in the modern era, which means that any context that enters its world sphere can actually direct its guidance and force it to accomplish or take care of actions that you wouldn't necessarily expect it to. If we scale this up to the CLI and SDK, perfect. You have an opportunity to leverage all these capabilities in any application that you integrate our harness into. And so this is a personal writing app that I use to hack on the Copilot SDK itself. I'll go ahead and I'll run a sandbox text. The way that I actually deploy agents out of here is I just write like I normally would in a file, and I can just @mention an agent, and it will deploy it. Because I'm actually using my @sandbox agent, which comes with these policies enabled by default, What I'm able to do is similar to the first demo, ask it to delete my desktop files. The sandbox will block the action. You will see the calls failing in there. And more importantly, you will see the agent providing its final guidance saying, the sandbox blocked my action. It's preventing me from doing this. You need to find another way around. Now, in a normal situation, I wouldn't want to find another way around. I don't want to delete files again on my desktop. So if we take a simpler, easier to manage scenario, such as creating a hello.txt on my desktop, I can show you what it's like to build finer and greater experiences for customers using the SDK. Again, all of these scenarios are available, and you can think about how you want to integrate them best into your solution. What's important about this one is I wanted to create a file. The sandbox blocked it. But because this is integrated in the SDK, and you can not only detect when the sandbox is in action, but you have an opportunity to perform other actions on behalf of the user, you can simply hit disable the sandbox, let it continue. I reviewed the command, which allows it to operate freely, create the file on the desktop. You should see this thing minimize in a second, and you'll notice there's a file there. Allowing you to not only put the sandbox in place as a great default out-of-the-box option, but put in user experiences and other controls that allow users to navigate safely around it when they run into it and they expect the agent to be successful.
Thank you, Patrick. So as part of us building all these platform capabilities, we actually work very closely with Patrick and the GitHub Copilot team to design and validate the design. But we also work very closely with the broader ecosystem as well, with partners like OpenAI, Manus, Hermes, NVIDIA, and OpenClaw. Stuart gave a great demo, and at the keynote today, you saw more about how Windows primitives are helping OpenClaw run more securely. So we covered a lot of ground in this talk. So let me go ahead and summarize the key things that you need to do to make sure agents run well on Windows. First, every agent should be running identified. It should have its own identity, distinct from that of the human user, with its own identity, permissions, and audit trail. It should run contained. Every action runs in the right sandbox, enforced by policy, and it also runs managed. Now, this is a topic that's going to require a lot more coverage, which we will cover in future sessions and blog posts and videos. But what we will do is I give a very high-level overview. At a high level, IT admin policies apply consistently across devices with full enforceability and observability. Now, if we go one level deeper, here's an extra feature you get as part of using MXC to build your agents. You get Agent 365 native integration. And this enables your agents running on Windows to start secure and stay secure. And this also means you get the full ecosystem as well. You get Defender, Entra, Intune, and Purview. Their protections allow your security and IT teams to constrain and secure local agents to make them run more securely in enterprise context. So that's really like a nice icing on top of this to take it back to where we started from. As agents move from answering questions and to taking real actions, the biggest challenge is ensuring they run well. Windows gives you the foundation to handle that shift, and Windows isn't just a place where agents can run. It's a place where they can run reliably, safely, and at scale. And with that, if you haven't done so yet, try MXC right now. What are you waiting for? And if you have any questions, want to talk to us further about any of these topics, come find Patrick, Stuart, and I at the Agentic booth, or some of our colleagues who will be there tomorrow to entertain more about these topics. Thank you.